Welcome back, Science Gang. I'm going to be going through the Relating Speed to Distance and Time booklet with you. I'm going to be doing some of the questions with you, and then at the end there's a little assignment for you to do. So if you take a look here, I just simply pulled this from the textbook, and I kind of got rid of some of the method that they calculated because I like to do my own method. So the photocopying isn't that great here, but of course you have this booklet in front of you. We've gone through all of this information already, but if you wanted to go through it, you certainly could. And it talks a bit about average speed versus instantaneous speed. What is the difference between the two? One of the questions you're going to be answering later alludes to that, so you can look at that. But right now I'd like to look at the sample problems that I've kind of whited out here and made room for us to figure them out together. So sample problem number 1 here. Eco skates to school a total distance of 4.5 kilometers. So right off the bat, write this down. 4.5 kilometers is the distance that we know. She has to slow down twice to cross busy streets, but overall the journey takes her 0.625 h, or hours. So we're given t, 0.62 hours. What is Eco's average speed? So it's a good habit, as you're reading, write the information down that you're given. Write a question mark for what it's asking for, and then you can easily determine what you need to do. And of course, if we take a look, revert it back to the triangle of terror, or pyramid power, VAV equals D over T. So we're just using the regular version of the formula here. We're looking for V, so it's D divided by T. Easy enough. Drop my marker there. Here we go. VAV equals D over T. So we have 4.5 kilometers over 0.62 hours. So dividing all that out, put that in your calculator, 7.3. 7.3. Now we have kilometers on top, hours on the bottom, kilometers per hour. So you should have enough room to copy that out. Once again, as I always tell you, if you run out of room, just press your extended page on the bottom of your page like that, and you can have more room. Okay? Looking at the second question. Imagine that you are running on the Caribou Dayliner. In the dome car, of course, and you see that a sign reads 120 kilometers. You decide after seeing several signs that you're going to measure the elapsed time between the next two signs, which are 10 kilometers apart. You read the elapsed time as 390.6 seconds. Determine the speed. Determine the speed of the train in kilometers per hour during the elapsed time. So we were given distance, 10 kilometers. We're given time, 390.6 seconds, and we're asked to find speed in kilometers per hour. Now this is kind of a tricky one because we're given kilometers, our distance is kilometers, but our time is in seconds. So there's a few different ways you can do this. Likely the easiest way is to convert this seconds unit into hours. So we know that there's 60 seconds in 1 minute, and we know that there's 60 minutes in 1 hour. So I haven't really gone through a setup like this, but I'm going to show you how to do it now. If we take a look at this, seconds cancel, minutes cancel with minutes, we'll be left with hours as a unit. And when you go on and take physical science courses, etc., or Chem 30, Physics 30, we'll look into this dimensional analysis conversion in more detail. You should be able to, at this point, figure out that in order to turn seconds into hours, you need to divide by 60 and divide by 60 again. So for an answer there, we get 0.1085 hours. So that 390.6 seconds converts into 0.1085 hours. And once again, we're asked to find V, so it's just the regular version of that formula. VAV equals change in distance over change in time. So our change in distance, of course, 10 kilometers, and our new determined time there, 1085 hours. Okay, so 10 kilometers divided by 0.1085 hours. When you work down your calculator, you should get 92. And our unit here, kilometers on top, hours on the bottom, kilometers per hour. So relatively easy there, except for that one little side calculation that we had to do in order to convert seconds into hours. Okay, we'll go through number 3 here. Kyra is trying to predict the time required to ride her bike to the nearby beach. She knows that it's a distance of 45 kilometers, and from other trips she can usually average around 25 kilometers per hour, including slowing down for climbing hills. Predict how long the trip takes. How long the trip takes? It's asking for time. And we should be given average speed and the change in distance that occurred. And if we look there again, oh, there's distance, 45 kilometers. Average speed, we're to, oh, right there, 20 kilometers per hour. So we're looking to find time here. Now if we use that good old pyramid of power, triangle of terror, whatever you want to call it anything you want, just don't call it lonely. So we're asked to find T, so of course D and V are what we have left over. D divided by V. My gosh, it works every time. So triangle T is equal to D over V. And let's see here, so T, so our distance is 45 kilometers. And our average speed is 20 kilometers per hour. And like in our other videos, there was another video we had like this. The unit manipulation is a little weird, but kilometers and kilometers cancel. The per hour in the denominator flips up to the top, so we actually get units of hours on top. And when we divide that out, it works out to be 2.3 hours. So relatively straightforward there. And I believe there's one more question here. Jana has a summer job helping with bison research. Big picture there of bison research happening like no one's business. She notes that they graze, which means move and eat grass for those of you who don't know what grazing is, at an average speed of about, now here's an interesting unit, 110 m/h. Now the m is not miles, it's actually meters per hour, because we're talking about bison here. They're not going to be running around at 110 miles per hour or 110 kilometers per hour, unless they have a red cape on their back with a big B. Now they're doing this for about 7.0 h/d. Now that represents hours per day in this case. So I'm glad I'm doing this hard one with you because it's a little bit tricky. Now at what distance in kilometers will the herd travel in 2 weeks? Okay, so in 2 weeks, how far are they going to travel? Now, so we know that they go, maybe we have a little side calculation we have to do here again, 7.8 hours per day, and they're doing this for 14 days. So if I just change this around a little bit, hours per 1 day, and they're doing this for 14 days, so I'll be able to get the total number of hours that these bison traveled for. 7 hours per day multiplied by 14 days. If you put that in your calculator, that works out to be 98 hours in total that they went. Okay? So at this point we could change this to kilometers or just simply work through it meters per hour and then convert it at the end, which is what I think I'll do here. So first of all, the good old pyramid of power, triangle of terror, average speed, distance, time. We're asked to find distance. V and T are side by side, so we kind of look at that as being multiplied. So change in distance is equal to average speed multiplied by time. And our average speed here is 110 meters per hour. Our time is 98 hours. So when we work that out, first we'll look at units. The hours and hours cancel, and our our distance will be in the unit of meters. Now it works out to be a fairly big number here, 10,780 meters. Now we can round that off to what we recall in science as two significant digits. So 10,780, I'll round it off to be 11,000 meters. And when you take physical science 20, you'll learn more about significant digits and rounding off. Now, it wanted it in kilometers, so we have it in meters, 11,000 meters. Quite easily enough here, when looking at unit conversions, there is 1,000 meters in 1 kilometer. So we can multiply by that conversion factor, or simply look at it as dividing by 1,000 meters. Meters cancel, and I'm left with 11 kilometers. Okay. We also have that staircase that we use for unit manipulation. You could have used that one as well. Okay, so there you have it. Now moving on in the assignment here. So we have the good old bison picture there. So I've circled the ones I want you to do on the assignment here. I crossed off the ones I don't want you to do. And the ones here I think are fairly easy. They're fairly straightforward. They're not like that bison one where we have a bunch of calculations within the calculation. Some of them here I have changed kilometers per hour to meters per second and vice versa. And in that other assignment we had a way of showing how to do that. So you can go ahead and finish those ones when you're ready.